So, today we will discuss about the third year 5th semester basic electronics. In that basic electronics, unit 11 voltage regulation. Okay. So, let us give about the introduction part of this voltage regulation. So many simple filters. So, that filter means here whenever we are using or we are converting in the case of a rectifier. So, that PN junction diode may act as a rectifier. So, here AC may be converted into DC. So, that in the output section some of the components of the AC which are present. So, that if you want to remove there we are using filters. So, that is LC filter, pi filter, L filter, whatever it may be. So, that these we have been discussed in the previous class. So, here the load voltage variations. So, across the load resistance, so we are getting the voltage output voltage. Due to this here there is a fluctuations, sometimes which may be increases, sometimes which may be decreases. So, in the AC mains voltage, okay. So, alternating current and fluctuations in the load current also. So, the constant voltage drop across the reverse biased Zener diode. So, okay. So, here the constant voltage drop across the load resistance when we are using the Zener diode in reverse bias condition, when it is going to be operated in the breakdown region, which is made use in the design of Zener voltage, which is a regulator. This you can call it as a shunt resistor. Okay. So, a transistor is used as a voltage controlled resistor in series with the power supply and load in electronic regulator. The series voltage regulator offers higher regulation without much wastage of the power in the regulator. So, let you go for the here why we need for voltage regulation. Okay. So, the voltage across the load connected to the power supply, which may be vary due to the following reasons. What are that? Here is which is cyclical variations in the rectifier output. So, just now we discussed about the what do you mean by rectifier means PN junction diode may act like a rectifier. So, pulsating AC which may converted into a DC, that is called rectifier. Okay. DC may be converted into AC means here that is a oscillator. Okay. So, here the fluctuations in the AC main supply voltage, that means 220 volts, 220 to 240 volts, and the frequency is 50 hertz. So, change in the load current across the load resistance we are taking as a output, that is a load current. So, here filters the case is that which are going to be minimized and also which cannot be eliminate the output voltage variations due to the fluctuations, that means sometimes which may be increases, sometimes which may be decreases due to the AC voltage. Then there is a variations you may be observed across the load resistance. So, however, here electronic voltage regulators which can be efficiently maintain the rated output voltage in spite of variations in main supply voltage and load current. So, they also serve as a filters to certain extent. Next, what here regulator characteristics. So, here from the figure you can able to observe that here an x axis load current IL is concerned and where y axis is the load voltage, that is V naught is to be concerned, and here where in this graphical representation you can able to observe the ideal power supply, that may be constant, that is going to be represented by the dotted lines, and whereas the continuous which may be here rated power supply, related power supply. So, here what is the typical characteristics of an ideal and real power supply, which are the output voltage from any real power supply, which is going to be decreasing with increase the load current. Okay. So, by increasing the load current, here real power supply which is going to be decreases from the graphical representation which is going to be showing here. So, here the amount of the regulation which is provided by the power supply which is to be indicated the percentage of the regulation What is the formula is that here the percentage of the regulation is nothing but a VOL minus VL. That means VO means load voltage minus with load. Okay. So that VOL is the output voltage under no load condition, and VL is the output voltage under load. Whenever load is concerned, there only we are going to be using this equation into 100%. Okay. So, the percentage of the regulation which may gives you the magnitude of deviation from the constant output voltage, and whenever it is going to be required. So, here the smaller magnitude of the percentage of the regulation which is better and also constant of the output voltage. So, for this conditions here, the voltage under any particular load current, according to the Ohm's law, you know pretty well, V equals to IR. The same thing we are going to be using here, the load voltage VL equals to IL into RL. That is the same formula we are to be using here. Okay. IL is the load current, RL is the load resistance. So, from that here, what is the R naught value? That means according to the definition here, the output resistance of the regulator, that is R naught, which may gives you here VOC minus VI, VL by IL. Okay. And also percentage of the regulation from the above equation, you can easily substitute that here, which may gives you here R naught by RL into 100%. So, here for any given load current, the regulation which may improves with respect to the percentage of the regulation as the output resistance or internal impedance. Okay. So, here internal impedance means V by I is nothing but impedance, that is to be denoted by Z here. Okay. So, here of the regulator, which is the Z value which is to be decreases here. So, that here hence which is a good regulator, and we should have a low internal impedance. So, the impedance value Z value which is going to be minimized. So, the case is that GNR regulator, how it may act like a shunt regulator. So, let me give you that first of all what is GNR diode. So, in this circuit we are using the GNR diode. So, GNR diode is the best example for the PN junction diode. In the earlier classes we already discussed about the PN junction diode. So, how the current which is going to be conduct the GNR junction diode. So, in forward bias the current is going to be, when the voltage is going to be increased, the current conduction is going to be simultaneously increases. Whereas, in the reverse bias the diode is not going to conduct at all. Why? Because of here the width of the depletion layer which is going to be gradually increases. So, the charge carriers which cannot be moved from one region into another region, that is what it is not going to be conduct the current here. So, the thing is that here the current conduction which may takes place due to the minority charge carriers, not by the majority charge carriers. So, here that is whatever the voltage which is to be applied to the junction here to conduct the current, that voltage which is related to the breakdown voltage. Okay. So, that at a time the current which is the covalent bonds at the junction which is going to be broken, here the current which is going to be simultaneously increases. That is the case we have been observed in the case of junction diode. But the thing is that here the GNR diode which is going to be act like a here a shunt regulator. That means here this GNR diode which is the best example for the PN junction diode. So, here in reverse bias, in forward bias also the GNR diode is going to be conduct the current, but the thing is that here in reverse bias, where along with the GNR breakdown voltage, avalanche breakdown is also going to be here you can able to observe. That is in the in previous section we already studied, but the thing is that here in regulation the GNR diode, you can able to see here from the circuit diagram, this is a variable source is there, that is the voltage, Vs is the variable source here, arrow mark which is going to be indicating here, you can able to vary, you can able to change here. So, here resistance, source resistance is Rs is there. Okay. So, that here whenever V and R is there, definitely there is a current Is is going to be generated according to the Ohm's law. Okay. So, here this is the negative section, this is the positive section, that means which is you have been connected in reverse bias, you can able to observe the case here. Okay. GNR diode which is the P type, this is a N type. So, that the positive terminal of the battery which is connected to the N region and the negative terminal of the battery which is connected to the P region, then you have to say that this is under reverse bias. So here what is the voltage which is come across the GNR diode is current is IZ, and here the applied voltage is VZ here, and we are taking the output across the load resistance RL, that is a load voltage, that is a regulated voltage. Okay. So here at input section, that is unregulated voltage which may fed through the GNR diode which become a regulated voltage. Is it clear now? Okay. So the thing is that from the figure we already discussed, so that whenever a unregulated DC voltage, that is a DC current, that is a direct current. Okay. So DC means direct, AC means there is a alternating current, there is a, you may observe the fluctuations. DC you may not observe the fluctuations at all. So DC voltage is VI, which is the chosen here greater than the GNR breakdown voltage, and which is going to be ensure that GNR which may be operates in the reverse breakdown region. Okay. So the unregulated power supply of the here reverse bias condition, the GNR diode which is going to be acting. So here the input voltage is Vi, which is chosen to be greater than the GNR voltage Vz. Vi is greater than the Vz, and the operation which is based on the here the fact that here whenever the GNR diode which is operated in the breakdown region, the voltage drop across the GNR which remains constantly and also consequently constant over wide range of current range. That means here whatever the voltage is going to be giving out here, the current remains same, current may be constant up to a wide range. So here this property which is made use of the design of the GNR voltage as a regulator. Okay. So here when the large change in the load current, so across the load resistance RL there is a VZ is there with GNR voltage, and we are taking the IL there. So which is a small changes in the GNR voltage due to the its low internal impedance. Impedance is Z equals to V by I. Okay. So the large variations in the current which is going to be following the here through the resistance RS and which may be produces the voltage drop across the counter. Okay. So if Is be the current drawn from the source here, and Iz and IL are the GNR current as well as the load current across the GNR diode. So that according to the Kirchhoff laws, we may be written as here II equals to Iz plus IL. So here input current which may be nothing but here the sum of the current which is passing through the load IL as well as the GNR diode Iz plus IL, and also V naught output voltage equals to Vi minus II, that is I input current and into RS, or else you can simplify this equation which may gives you here source resistance RS value which is Vi minus V naught by II as well as Vi minus Vz by II. So by simplifying this and doing the calculation part, you may get the Dii equals to Diz, the change in the input current which is equals to the change in the current across the GNR diode. So that whenever the DC supply voltage which is altered, if it is going to be changes here under the constant load resistance, so the current II and the GNR current Iz which may change equally to keep the load resistance constant. So that is what we are using here. GNR regulator is a shunt regulator. Next is the electronic regulator and series regulator. Okay. So here a large regulations with better regulation that can be visible with a simple GNR regulator. Okay, which is you can able to see the diagram here. The electronic regulator, voltage regulator RS and series resistor to the GNR current. So here also at input section this is a unregulated input voltage Vn. Here this is a op amp is operational amplifier is concerned. Here GNR diode is there, RZ is there, and this is the 741 IC 741 operational amplifier is concerned, and across the load resistance RL we are taking as a regulated voltage, output voltage. Okay. At input section, through the electronic regulator, which is a series regulator, we are sending the unregulated input voltage. Unregulated means which may not be a constant here. So, a regulation means whether the signal strength may be increases, whether the output voltage may be constant. Okay. So, that is the case you may be observed here. So, the output voltage such a regulated circuit which is controlled by introducing power transistor, that is here Q in the series with unregulated power supply across the load resistance Q. So, here you may be observed here, this is the transistor. So, that in this Zener diode is using here, operational amplifier is using here, a transistor is using, 3 components we are using in this circuit. So, Q is known as a series pass transistor, and what is the internal impedance, and here hence the voltage across it can be varied from the opposite to the change in the output voltage. Okay. So, here the transistor Q is going to be act like a variable resistor in series with the load resistance RL. So, what is the collector to the emitter voltage C to E drop across the series pass transistor, which is known as, you know pretty well, that VCE minus VI minus VL, VC equals to VI minus VL. So, here a fraction of the output which is fed into the input signal, that is called here feedback. That feedback is also going to be observed in the case of this concept. So, here a part of the load voltage, that is beta is a feedback constant and VL is the load voltage which is sampled and fed into the inverting input of the operational amplifier via resistor R1 and R2, which is a potential divider network. From the diagram only we are discussing all these concepts. So, the feedback factor beta is nothing but a R2 by R1 plus R2. And also here what is the sampled voltage which fed through this operational amplifier means here Vf equals to beta into VL. Okay. Feedback, what is mean by Vf? Vf is nothing but a feedback voltage, beta is the here feedback constant and VL is the load voltage. So, this voltage is compared with the reference voltage of the Zener voltage, that is Vz, which is provided by the Zener diode. Okay. Next is the versatile variable voltage IC regulator, that is IC means integrated chip. So, integrated chip to 73 IC 723. So, here you can observe the diagram here also. What is the diagram, the figure which is indicating here internal schematic circuitry of LM723 IC voltage regulator, which may be act like a positive voltage regulation. So, here also you can able to observe that at input section we are giving a unregulated input voltage and we are taking as a output is a regulated output voltage. Okay. How the regulation which are to be takes place by different circuits where we are using the Zener diode. Here also we are using the Zener diode, you can able to observe the circuit diagram. Okay. And op amp is also going to be using the different transistors Q1, Q2. Okay, different transistors as well as the capacitor is also going to be used here. Okay. So, the thing is that here the what do you mean by versatile variable voltage? Variable means you can able to change the voltage. Okay. So, the electron voltage regulator which can be fabricated on a single chip. So, nowadays we are using by the implementation of the nanotechnology, a large circuit may be reduced into a small. So, that is the technology, semiconductor technology we are using to generate a new types of ICs, chip, all. Okay. So, here which is a low cost and high performance, this IC723 is a low cost and high performance and which is also size in small also, and you can easily use it, and the basic circuit which may be implies in this. So, here another one is the circuit diagram of positive voltage regulator using 7232 IC. So, this is the another IC 7232. So, here this circuit which consists of voltage reference source. So, Vs and which is an error amplifier. So, what do you mean by amplifier? Means which can enhance the signal or which can strengthen the weak signal. Okay. Whenever a weak signal fed through the amplifier, which is going to be strengthened. Okay. So, here a series pass transistor, is going to be using here. Transistor transmitting the signal using the resistors and a current lifting the transistor and a positive voltage regulator circuit. So, you can easily see that here at input you may observe that this is a regulated DC output. So, this is a regulated DC output and here which is a unregulated DC input. Okay. So, here this is a DC output here regulation through this IC when you are it is going to be feeding through the voltage. So, that which may be regulated here, this is unregulated before that when it is passing through the IC 7232. So, here you can able to observe the IC here different pins are there, how many pins are there here. You can see here 10 pins which is to be denoting here and what pin it is to be connected that is internally which may be given to that particular IC. So, here which are indicating here resistors are there, so many resistors which may be used here. So, that may be followed this condition. So, here input is also as well as the output is also two capacitors are to be used in here C1 as well as the C2 capacitors. So, next is the fixed voltage IC regulator. So, fixed voltage IC regulator. So, here IC 723 LM 317 here is there. So, here 723 IC 723 which is a sophisticated versatile regulator. So, the voltage to be unregulated become a regulated. So, here which requires some designing, so that how previously what we have been observed and presently how the technology which is going to be improved here to reduce and to get the here based on the concept here what we have to get, what we have to achieve. So, that was only the designing of this circuit is going to be takes place. So, here so many here implementation and applications only certain fixed voltage which is to be required here. So, here no need to be changed here the voltage for such application which is specialized with the fixed voltage. So, the heading is itself it is showing that the voltage is fixed, you cannot be changed, variable, it is not variable. Okay. So, here the ICs which are to be developed and which is also very simple to use, and here they have only 3 terminals for a fixed voltage IC regulator. When it is unregulated input voltage is applied to the input terminal, then the regulated output which is taken from the here the input terminal and the reference are the adjustment of the terminal which is normally bounded in the some cases and which is to be maintained at a certain reference voltage also. So, here you can able to observe that this is the input voltage, this is the output voltage we are considering, and this is the IC here. Okay. LM 317 this is the input voltage and this is the output voltage. So, here ADS is also there, and here the fraction of the output which may fed into the input here, that is also to be concerned. So, potential divider R1 and R2 is there. So, this may be gives you the fixed positive voltage regulator. Negative voltage is also there, that is this is the negative voltage regulator. So, here which is we reference voltage which is derived from the regulator. So, that there are both positive voltage regulators and negative voltage regulators we have been observed. So, that here the voltage retains vary from 5 volts, 6 volts, 9 volts, 12 volts, whatever it may be here, and the current rating which can be vary between the 150 milliampere to the 1 ampere. Okay. Milli means 10 power minus 3 amperes of current to the 1 ampere of current. So, that the positive voltage regulators are LM 317. So many the series is there here. So, that where the here XX in the above condition, which may be considered as 0.5, 0.8, whatever it may be here. So, the similarities which may gives out here. So, this is the case. Next. So, what about the fixed 3-pin positive voltage regulator, and this is the fixed 3-pin negative voltage regulator. You can able to observe the two cases here. So, the this is a solid, here a transparent capacitor is there, C1, and this is the C2 here. So, this is the IC78XX. In place of double X, you can put it as a previously what they said. This is the input capacitor, this is the output capacitor, load resistance, and V0 is plus XX. Okay. Regulated voltage. This is the unregulated voltage which fed through this here, then this become a regulated. So, that this is only 3-pin positive voltage regulation. What are these 3-pin means? Here first pin is there, here you can see this is the first one, this is the second one, this is the third pin. Only 3 pins have been used to get the regulated voltage, okay, if it is a positive voltage regulation. Next is the negative voltage regulation. Here also 3 pins. So, that IC is changes here 79XX. So, it's the same thing, unregulated voltage is there, and across the C1 and 3 pins 1, 2, 3 is there, 79XX, and this is the load resistance, a capacitor, and this becomes a regulated output voltage. So, that what is the regulated output voltage? V0 becomes minus XX. Here V0 is plus XX. Okay. The only the thing is that ICs are different, 79XX, 79XX. SMPS. So, what do you mean by SMPS? Means switch mode regulator power supply. SMPS means switch mode regulated power supply. So, here whenever the input to step down transformer, which is bulky and it is the most expensive component because its operating frequency is very low, that is 50 hertz. So, that here low frequency large value of filter capacitor is required to decrease the ripple. Okay. Ripple means I already told you, whenever a conversion is going to be takes place AC into DC, some of the components of the AC which may present at the output. Okay. So, those are called the ripples. How we are going to be removing those ripples? By using the filters only you can easily remove the ripples. So, what is the efficiency here which is very low? Why? Because of here the difference between the input and output voltage is very high. So, this results is a large power dissipation across the series pass transistor. And the third one is that the linear mode power supply required here additionally, that is a plus or minus 15 volts DC supply to operate the active device such as the operational amplifier, and it may not be economically and practically feasible in all the conditions. So, for a specified range of input to and output variation, linear regulator maintain a constant output voltage by dissipating XX power as a heat here. Okay. So, due to this reason the linear regulator is suited for medium current applications only. So, here this is the basic diagram of the here SMPS. So, it may includes the here AC input, here a rectifier is there, switching circuit is there, step down transformer, rectifier and filter, simple circuit, error amplifier, and PWM, that is here pulse width modulated. PWM means pulse width modulated, and here steering and logic circuit. So, here this is a triangular wave is going to be generated here. You are giving that. So, what are the advantages? You can go for the advantages here, SMPS advantages. So, the linear line frequency is 50 hertz, okay, step down transformer, and which may block the bulky of the costly. So, here disadvantages also there. Okay, it is not required any step down transformer. So, this is the comparison of the linear power supply. So, this ends our here voltage regulation here. So, that how the GNR diode which may be act as a voltage regulator and shunt regulator. Okay. Different types of ICs, unregulated power supply which fed to the ICs here, how it become a regulated power supply, that is also discussed, and finally, we have been discussed about the SMPS. Okay. So, this ends our voltage regulation. Thank you.